Jim Hilliard, Auburn University, USA. This is quite favorable to stocks. In some kind of equilibrium, you'd think that many people would be somewhat indifferent between stocks and bonds. However, governments are heavily involved in bonds.
Issuing bonds and buying bonds.
Well, and
right.
the Federal Reserve Banks.
Right.
And so this kind of maybe distorts the market a little bit. Could this be the reason why it seems that stocks tend to outperform, under many scenarios, bonds? But that is a fact. In the private market, stocks are pretty much left to the wiles of the private individuals, whereas bonds, they
fluctuate
are
less
to central banks.
Yeah. What you mean, that stocks fluctuate much higher than bonds? This is what you mean?
Yes.
Sure. This is the whole idea. If you invest for short period, stock fluctuate more than bonds. And if I want to see every day, look at the iPhone, if I lost money or made money, don't buy stocks because you get heart attack. I prefer that if you invest, if you are young or invest for your children, whatever you want, or for saving, I buy only stocks. I don't buy bonds, but don't look every day in the iPhone because this is really irritating. If you lost 22%, or in 2008 you lost 50%, but what happened in 2009? You won 100% or 90%. So this is the whole idea. Stocks, if you look from, just one more sentence, if you look from 1929, including all the crises, stocks making arithmetic mean of 12%, geometric mean of 10%, and bonds making 3%. Now, one thing that I was amazed, Treasury bills, which are the safest investment, they're making for 100 years 3.1%, and the inflation in the US is 3%, which means for 100 years, people invest for 0.1. Actually, they invest for negative return. You know why? They pay taxes on the 3.1%, no inflation adjusted, and in the Reagan era it was 50% tax. So from 3.1, what left is 1.6, inflation 3%. How can you explain to me people rational investing 100 years, not 1 year? 1 year you can make a mistake. You think the inflation will be low, but suddenly it's high. For 100 years, rational expectation, I don't know how to explain it, people invest in negative return because they're afraid of the fluctuation in the stocks. Thank you.
Okay, so we are a little bit late on time, so just 2 questions, please.
Yeah, I'll just ask. Is it on? Can you hear me?
Yeah, I hear you.
Okay. This is Mulay Bhattacharya. I'm from India, IIM, Indian Institute of Management, Bangalore.
Okay.
I have one question. That is the first part when you are fitting the distribution as log normal for t more than 20. And t less than 20, it is kind of not very clear, right? What distribution it will fit.
For smaller t?
The small t. Yeah, small, big T, yes. So I was thinking that, did you look at the kurtosis, the fourth moment of the distribution? And if you did look at it, perhaps there are options available in the kitty of distributions. Johnson's SU, Pearson type 4, these can be used? Yeah, that is what I wanted to know, that did you look at? Okay.
The distribution that Crystal Ball takes into account. Crystal Ball is a program which takes 50, I think 20 distributions, which are commonly employed in economics and statistics, and try to fit them all into the data, including kurtosis. For example, the uniform distribution is kurtosis. Normal distribution is also kurtosis of 3. So they take into account kurtosis, and this is the best fit, taking all parameters into account, all of them. So I take everything into account, not me, the program takes it into account. In addition, I want to tell you that people in economic and finance know what is mean, know what is variance, know what is skewness, if you like it or not, and don't understand kurtosis. There is a paper by Kaplansky, Jassa, 1952, showing that kurtosis is not what people think. Exactly. So you don't know how to evaluate it if you can I want it to is a paper, mean variance skewness efficient frontier, taking 3 of them into account. Because skewness, we know that all of us like positive skewness. Because error prime decreasing absolute risk premium, implying that we like skewness. This we know, but control, we are not sure.
The point that I have in mind is the moment we are talking about risk, okay, and if it is negative skew, particularly when we are talking negative skew, okay, and if you are talking about in terms of maximum loss that one can incur. So skewness basically it is going to the negative, and kurtosis tells you that it is going to be a fatter tail than the normal distribution, as I understand. And therefore, the chance of getting a large amount of loss is higher than if you did with a normal distribution. So that's the point that I was trying to.
The negative skewness, actually, many people try to develop different investment goals like safety first and other rules which take into account the negative part of the distribution. But I tell you, and I show you, that if the horizon is 20 years or more, it's not normal with positive skewness. Short horizon, I admit, I don't know how to solve it. If you tell me you invest for 2 years and you for 4 years, I don't have a rule for you. I don't know. Unless you tell me the returns, the range of returns is very small, minus 30% to plus 30%, you can use approximately the mean variance of market. But if it's more wild, like option, you can go minus 100%, plus 500%, you can include it. Then I talk with Marcos about it. They say ignorance. So it's my partial answer.
One more question, sir.
Sorry.
So this is regarding your analyzing the risk, where you divide it by t. So one thing is that mean changes linearly and risk changes exponentially. We all know risk changes exponentially. That was one of the problem you already mentioned with dividing by t. So why don't we divide it by t square? It will not be closer to reality. It might not fit the distribution, but at least it will give a factor to the possibility that in risk, the branching is happening at each point of t.
Okay, what's your name?
Mrityunjay from IIM Lucknow, India.
Okay. First, identify that thing. This combined poster, I think is wrong. And secondly, what you suggest, let's divide by t square, they did something like that. They took log of return, which kind of dividing, and they divide by t, and then they got stable numbers. So it's not, I think the divide by t of this graph is wrong. Wrong?
Okay, the last question.
Couple of questions. In life, the horizon may change with time. In other words, what I plan today, maybe I plan today to have an horizon of 10 years, and then in 5 years, for some reason.
The horizon is random variable.
Exactly, the horizon is random variable. So first question, did anybody, you or anybody else do the same kind of work that you are doing for random horizon? This is question number one. Question number two, you mentioned in this very interesting discussion that you had just now, that all those returns, they don't take into consideration inflation, and they don't take into consideration the tax system. I wonder whether the calculations that you made are calculations that you showed us, have all those calculations. Do they take those things into consideration, or they are gross without taking those into consideration? Or so, in other words, is it real calculation, taking the tax system into account, or not?
The first question, I'll try to repeat it. What happened? Here I assume horizon, which is fixed, 5 years, 10 years, 20 years, etc. And what my friend Alex asked, what happened if the horizon is random variable? I don't know what the horizon. I can say 20%, that will be 10 years, probability 5% be 30 years. Actually, there is a PhD student of mine who did a whole PhD and published one paper on this topic, what happened with the horizon, which is random variable. There is a paper on that. Very complicated. He's a mathematician. I'm trying to understand what you wrote. I approve his PhD, but I'm not sure I understood. Okay. Secondly, it's Cohen, by the way, from Israel. Secondly, most papers, not all of them in finance, are nominal. You are right. But there are some papers which are also inflation, taking inflation into account, and taxes on dividend. There are also these papers. You have all kinds, but most people, you are right, are nominal. I don't believe if you take after tax and after inflation that these things will change. Stocks making, let us say, 10%. I give you the numbers. I talk about averages now. Stock making 12% on average, 3% inflation, so making 9% real terms. Bonds, treasury bills making 0. After tax, the gap is even increases because treasury bills are negative return. I published this paper too in Financial Analyst Journal, minus 1.7%. So there is a lot of room to continue to work on this. Therefore, in particular, I encourage you, the audience, if someone will tell me or help me how to find some rules for different horizons together. And the last thing that I want to say, unless you have one more question, there is in the United States life cycle mutual fund. Did you hear about them? Or called target funds. What they do, when I put their, let's say, $1 million, no, I don't have $1 million, my wife put their $1 million, they invest for her when she's young 100% in stocks. When she grows older from 30 to 35, they decrease it to 80% in stocks. When you are 60 years old, they increase it to 10% in stock, which is in line of what I said here. If the horizon is very long, stock dominates bond, buy a lot of stocks. As the horizon decreases, they shift more to bonds. And this is in line with what I did here today. Not perfect, but in line. And life cycle mutual fund, called also target funds, are very popular in the United States. Billions and billions of dollars invested in them. So there is some logic to what I did here or what they do there. Yeah. Any more questions?
Okay.
So thank you very much.
Thank you very much.